Nature's complexity is a subject that has mystified and intrigued scientists for centuries. How can we possibly understand the intricate patterns and processes that govern the world around us? Ian Stewart takes us on an enlightening journey through mathematical insights and helps us demystify the complexity inherent in nature. Hey there, fellow science enthusiasts. Welcome back to our journey through Ian Stewart's fascinating book, Nature's Numbers. Today, we're diving into Chapter 4, titled The Constants of Change. Get ready for a mind-bending exploration of the dynamic interplay between mathematics and the ever-changing world of physics. In this chapter, Stewart takes us on a historical journey, exploring the two contrasting views of the universe that have shaped human thought for centuries. One viewpoint suggests the universe operates under fixed, immutable laws, while the other asserts that everything is in constant flux, ever-changing. As Heraclitus famously said, "You can't step into the same river twice." Over the years, science has predominantly adhered to the first viewpoint, but Stewart points out that we're witnessing a shift. Contemporary perspectives, such as postmodernism, cyberpunk, and chaos theory, are challenging the idea of an objective reality. This rekindles the age-old debate about rigid laws versus flexible change. Stewart suggests that instead of pitting these worldviews against each other, we should seek a higher order of reality, viewing them as complementary shadows of a greater truth. But, does such a higher order exist, and is it accessible? To many, Isaac Newton represents the triumph of rationality over mysticism. The famous economist John Maynard Keynes had a different perspective. He saw Newton not as a pure rationalist but as the last of the magicians, and the last great mind who viewed the world through the same eyes as those who built our intellectual heritage thousands of years ago. Now, let's dive into the core of this chapter. Stewart highlights Newton's groundbreaking approach to motion. He explains how Newton's laws of motion shattered the static model of nature held by mathematics before him. Newton's genius was in recognizing that although the path of a cannonball might seem complex, its velocity follows a simpler pattern. By decomposing motion into its horizontal and vertical components, he revealed the elegance of his laws. Newton's laws state that the acceleration of an object is proportional to the force acting on it and inversely proportional to its mass. This simple relationship revolutionized our understanding of how objects move. Stewart also introduces us to the concept of differential equations, which describe rates of change in nature. These equations are the backbone of modern physics. They relate to how physical quantities change over time. The chapter delves into the infamous three-body problem, which arises when trying to predict the motion of three interacting masses in space. Unlike the two-body problem, it's not integrable, meaning we can't find simple formulas to describe it. Mathematician Zhihong Xia's work in 1994 revealed the chaotic nature of the three-body problem. This chaos, known as Arnold diffusion, creates a seemingly random drift in orbital positions. So, there you have it, Chapter 4 of Nature's Numbers by Ian Stewart, where we explored the dynamic dance between mathematics and the ever-changing world of physics. As we move forward in our journey through this book, we'll discover even more exciting revelations about the hidden patterns of our universe. Thank you for joining us on this intellectual adventure. If you enjoyed this vlog, don't forget to hit that like button and subscribe for more mind-expanding content. Stay curious, and we'll see you in the next chapter of Nature's Numbers.